Hey guys, welcome to Chapter 9, Topic 3. So we talked about physical controls in Topic 2. Now we're going to talk about chemical controls. And while physical controls are really important to be aware of, chemical controls are something you're going to be far more likely to use because they're a little bit more portable and they're a lot easier to use like in a quick situation to clean something up. In fact, you guys are already using chemical controls every day in lab. This is when you wipe down your bench before and after lab and other various chemical controls you've used throughout lab. So why is this topic important? Just like I said, physical controls are really important, but chemical controls are a main tool that you're going to use in a healthcare environment. So make sure you really understand the different classifications of these controls so you can have a good handle on which ones are going to be effective for which kind of situations. All right, so let's start out by how do we select antimicrobial chemicals? Chemical agents can be liquid, gas, or solids. So it's not just a liquid. We always think about them being liquids, but they're not always just liquids. And they can do any of the following things. Antiseptics, which remember are only used on the skin. Disinfectants, which only knock down the amount of microbes present. Preservatives and sterilants. And sterilants are the ones that can kill microbes. So just be familiar with the different ones. And no chemical can completely fulfill all these qualifications that we're going to talk about here next in our considerations. Glutaraldehyde and hydrogen peroxide are the closest that we have, but there's some considerations that we want to look at. You always want it to be effective in low concentrations. You don't want to go crazy spreading chemicals everywhere. If you can have it soluble in water or alcohol, that's really super helpful because it makes it easy to dispense and easy to mix up. Broad spectrum action is always the best because remember, anytime you're going to have microbes on a surface or on your skin or anything, you're going to have a mixture. It's not just a homogeneous setup, it's going to be all sorts of things. So the broader the action of the chemical, the better. Penetration is always important as well. How can it kill if it can't get through to wherever it needs to be on the permeable surface? You want it to also be resistant to being inactivated. So if I were to put it on the bench top, I don't want it to react with the bench top and become inactivated. So that's another consideration for it. We then have, you don't want it to be corrosive to your surface because otherwise you're going to be replacing your countertops or your surface tops really, really often. So you want that to be good too. And sanitizing, deodorizing properties, does it actually do that? Does it work? And is it affordable and is it ready to use? Is it easy to use? Those are all considerations we have when we look at types of chemicals. So now let's look at the types of chemicals we have. Now the ones that are in pink over here are sterilizing, which remember is capable of killing organisms, whereas the ones on the in the yellow are only capable of disinfecting. So let's take a look at a couple of these things. First of them, we have halogens. We got a couple different halogens. We got chlorine, we got iodine, we got peroxides. And remember, as I said, hydrogen peroxide is really effective, but unfortunately, it's got a lot of drawbacks. That means it doesn't work very well. And these work to kill spores and all microbes. This is why we use bleach for a lot of things, because it's really effective that way. We then have aldehydes and we have gaseous sterilants slash disinfectants. And you don't see those a whole lot except for in specialized situations because the gas is a little bit harder to work with, especially because it can be inhaled and things like that. So it's really important that you be careful with it. So the ones that you're going to be most familiar with, the ones you've probably seen the most are chlorine, iodine, and hydrogen peroxide. You know, if you go to get a blood sample or anything, people will put iodine on your skin to sterilize the area. So it's just a variety of things like that. So then let's look at our other types. We have phenol, chlorhexidine, alcohol, detergents, and heavy metal compounds. So these are all capable of disinfecting, not sterilizing. So they're effective for vegetative cells, sometimes they're effective for viruses, they're effective for a variety of actions. And so I want you to look through these charts. I'm not going to read them to you all, but I want you to look through these modes of action and pay attention to that. Remember, we had 4 sites, 4 cell targets, and I want you to realize and correspond these to those actions. And we're going to do some activities in class to help with that, but I really want you to focus in on these. So pay attention to that as well as the limitations, like why do you not want to use a ton of bleach? What could be a problem with bleach? And you can see here from the chart that it's less effective if light is exposed or if it's alkaline pHs or there's other organic matters around. So there's always limitations to all these. That's why there's no perfect chemical. So pay attention to these charts and let me know if you have any questions or if you want to talk through them a little bit more. But I don't want to bore you with reading the chart to you through this lecture. So one other thing we have, and these can be effective, but the problem with them is that they can ruin the surfaces of whatever you're working with. And these are dyes, acids, and alkalis. Obviously, dyes are going to leave some kind of colored residue on the surface. And an example of this is some of the dyes that we use in lab. For instance, crystal violet is a highly effective antimicrobial. But do you really want your countertops purple? So that's where these aspects come in. So usually they'll use small amounts mixed into other household cleaners. So if you see something that's got a little bit of a dye to it, that may be what it is. And so you can see how some of these are mixed in here with the household cleaners. And I want you to be familiar with some of these. I don't expect you to memorize this chart, but I do want you to have some sense of where we see some of these things again. For instance, what do we see using halogens? Do we see some of those items that we saw in our previous chart, the slide before, mixing into our household chemicals? And do these acids or dyes play a role in them? So pay attention to that. But overall, the big thing I want you guys to focus on in this topic goes back to those charts in the last slide. Make sure you understand the different classes. And as I said, in class, we're going to really focus on some activities, discussions, to really make sure that we get those household cleaners understood and clear. So this is the end of this topic lecture. Please let me know if you have any questions or if you want to go through some of these classifications again. Thanks. Bye.